Physics paper question 1. The dimensions of calorie are. Now calorie is a unit of heat energy and the dimensions of heat energy are m, L raised to 2, T raised to minus 2. So your correct answer would be option A. Question 2. The length, breadth and thickness of a metal block is given by L equals 90 cm, B equals 8 cm and thickness 2.45 cm. The volume of the block is. Now the volume of the block here would be, correct answer would be option A. Just that is, volume of a block would be length into breadth into the thickness. That would give you option A as the answer. Question 3. A body dropped from a height h with an initial speed 0 strikes the ground with a velocity 3 km per hour. Another body of same mass is dropped from the same height h with an initial speed minus u equals to 4 km per hour. Find the final velocity of the second body with which it strikes the ground. Now in case 1, we have v square minus u square equals to 2gh, v square being 3 square and u square, since initial velocity is 0, so that will be 0. So basically we'll get 3 square equals to 2gh. In the second case, it will be v square equals to minus u square plus 2gh. Now u is known to us as 4, so 4 square, and 2gh is known to us as 3 square. So basically 4 square plus 3 square will be equal to your v square, which is basically, now 4 square plus 3 square would be equal to 25, which, so v square will be equal to 25, so v will be equal to 5 km per hour. So correct option would be option C. Question 4. A mass is supported on a frictionless horizontal surface. It is attached to a string and rotates about a fixed center at an angular velocity omega 0. If the length of the string and angular velocity both are doubled, the tension in the string, which was initially T0, is now. So we have to find what is the tension in the string. Now tension in the string T0 will be mr omega 0 square. Now the new tension T would be m, radius becomes twice, 4 omega 0 square, which basically becomes 8 times mr omega 0 square, which is 8 times your initial tension. So your correct answer here would be option D, 8T0. Question 5. A 2 kg stone tied at the end of a string 1 meter long is whirled along a vertical circle at a constant speed of 4 meters per second. The tension in the string has a value of 52 Newton. When the stone, so we have to find, basically the tension in the string will have a value of 52 Newton when the stone is present either at the top or halfway down or at the bottom, or none of the options are correct. Now mass is given as 2 kg, radius is 1 meter and v is 4 meters per second. Tension in the string at the lowest point will be mg plus mv square by r, which will be 2 multiplied by t plus 2 multiplied by 4 square divided by 1, which is 52. So basically we have to do a trial and error method where we can find tension at the lowest point, tension at the highest point, and whichever one gives the correct answer, that's the correct option. So here TL value is coming out to be 52 Newton. So your correct answer would be option C. That is, a given tension of 52 Newton is at the bottom of the circle. Question 6. A nucleus disintegrates into two nuclear parts which have their velocities in the ratio 2:1. The ratio of their nuclear sizes will be. Now according to law of conservation of momentum, m1 v1 will be equal to m2 v2. So m1 by m2 will be equal to v2 by v1. Now m is 4 by 3 pi r cube rho. That is basically volume into density. So mass is directly proportional to r cube. So I can say that m1 by m2, which is equal to r1 cube by r2 cube, will be equal to v2 by v1. Now ratio of the velocities are given as, that is v1 by v2 is 2:1. So v2 by v1 will be 1/2. So r1 by r2 will be equal to 1/2 the whole raised to 1/3. So R1 is to R2 will basically be, correct answer, option D. Question 7. A machine gun fires 20 bullets per second into a target. Each bullet weighs 150 grams and has a speed of 800 meters per second. Find the force necessary to hold the gun in position. Now here, force will be m into number of bullets multiplied by the velocity. So m, that is given as 150 grams, that will be 150 multiplied by 10 raised to minus 3 multiplied by number of bullets being 20 and velocity being 800 meters per second. So finally we'll get the answer of 2400 newtons. Your correct answer is option D, 2400 newtons. Question 8. 4 smooth steel balls of equal mass at rest are free to move along a straight line without friction. The first ball is given a velocity of 0.4 meters per second. It collides head on with the second one elastically, the second one similarly with the third one, and so on. The velocity of the last ball is. So we have to find what is the velocity of the last ball here. The first ball has a velocity of 0.4 meters per second. Now, if after the collision of two bodies, the total kinetic of the bodies remains the same as it was before the collision, and also the momentum remains the same, then it is a case of perfectly elastic collision. That is, here, since it is mentioned, the collision is elastic. So momentum before and after collision would be same, and kinetic energy before and after collision would be same. Hence I could say u1 minus u2 will be equal to minus of v1 minus v2, where u1 minus u2 is the relative velocity before collision and v1 minus v2 is the relative velocity after collision. Thus, in a perfectly elastic collision, the relative velocity does not change. Hence, the velocity of the last ball would be minus 0.4 meters per second. So, your correct answer would be option A. Question 9. 3 bricks each of length L and mass M are arranged as shown from the wall. The distance of the center of mass of the system from the wall is. So we have to identify how far is the center of the mass of these 3 discs from the wall basically. So here, for the lowermost disc, the center of mass would be the center of the disc. Same way for the second disc it will be the center, and same way for the third disc. So center of mass of the lowermost disc is at a distance, suppose x1 from the wall. Center of mass of the second disc is at a distance of x2 from the wall, and center of mass of the third disc is at a distance of x3 from the wall. So each of the center of masses of each of the disc is at a distance of x1, x2 and x3 respectively. Now x1 will be L by 2, x2 will be L, that is basically, since x2 is nothing but the length of the entire first rod, x3 will be L plus L by 2. So x3 would basically mean it is L plus L by 4 actually. So since x3 is at a distance here, so this would basically mean L plus this much, that is L by 4. That will basically give me 5L by 4. So x1, x2, x3 values are known to me. Now the center of mass of the whole thing, x, would be m1 x1 plus m2 x2 plus m3 x3 divided by m1 plus m2 plus m3. So on substituting all the values, you will get the value of x as 11L by 12. So basically the center of mass for the entire system from the wall is 11L by 12. So option D is your correct answer. Question 10. A particle of mass m is rotating in a plane in circular path of radius r. If angular momentum is L, the central force acting on the particle is. Central force acting on the particle, that is basically centripetal force, is mv square by r, which will be m by r. V square can be written as L square by m square r square. So this will basically become L square divided by m r the whole cube. So your correct answer here would be option D. Question 11. The mass of the earth is 6 multiplied by 10 raised to 22 kg. The constant of gravitation capital G would be 6.67 multiplied by 10 raised to minus 11 Newton meter square per kg square. The potential energy of the system is minus 7.73 multiplied by 10 raised to 28 joules. The mean distance between the earth and the moon is. Now this you can either go ahead and solve the equation or just also remember that the mean distance between the earth and the sun is actually 3.8 multiplied by 10 raised to 8 meters. That is option A. If you want to solve it, you will use the equation U equals minus G M capital M small m divided by R. So R would basically be minus G capital M small m divided by U. You know all the values given in the question, substitute, you will get the answer as 3.8 multiplied by 10 raised to 8 meters. Question 12. There is no change in the volume of a wire due to the change in its length on stretching. The Poisson's ratio of the material of the wire is. Now first thing, volume of the wire is pi r square L by 4. Now this volume depends on the radius. Now here since the wire is stretching, the radius is continuously changing. So let us say this volume is pi x square L by 4. X is the changing radius as the wire is stretching. On differentiating dV by dx, we will get pi by 4 2xl plus x square dl by dx. As the volume remain constant, dV by dx would be equal to 0. So this whole right hand side will be equal to 0. So we will get 2xl plus x square dl by dx equals to 0. So we will get 2xl equals to minus x square dl by dx. Now dx by x divided by dl by L would be equal to minus half. This basically left hand side represents your Poisson's ratio. So that is basically Poisson ratio would be option B. It will be your correct answer, minus half. Question 13. Two raindrops of same radii r falling with the terminal velocity v merge and form a bigger drop of radius r, capital R. The terminal velocity of the big drop is. Now terminal velocity is given by 2 by 9 r square rho, that is density, minus sigma g divided by eta. So from here we can basically say V is directly proportional to r square. So V by small v by capital V will be equal to r square divided by small r square divided by capital R square. So basically a capital V will be equal to small v r square divided by small r square. So the correct answer here would be option B. Question 14. Angle of contact of a liquid with solid depends on. Here the correct answer is it depends on the orientation of the solid surface with the liquid. That is, angle of contact definition is angle inside the liquid between the tangent to the solid surface and the tangent to the liquid surface at the point of contact. Hence the angle of contact actually depends on the orientation of the solid surface in liquid. Question 15. A composite rod made of copper, alpha values given as for copper is 1.8 multiplied by 10 raised to minus 5 per Kelvin, and steel, so alpha value of steel is 1.2 multiplied by 10 raised to minus 5 per Kelvin, is heated. Then what happens? So here in this question, if LT is the length of a rod at T degrees Celsius and L0 is the length of the rod at 0 degrees Celsius, then we know that LT is equals to L0 1 plus alpha T, where alpha is the coefficient of linear expansion. So basically we can see that LT depends on alpha such a way that if alpha increases, LT will also increase. Now alpha for copper is greater than alpha for steel given to us. Therefore copper will expand more compared to steel, because of which your correct answer would be option A. It bends with steel on concave side. So basically because alpha for copper and alpha for is greater than alpha for steel, rod bends with copper on convex side and steel on the concave side. Question 16. A thermally insulated vessel contains an ideal gas of molecular mass m and ratio of specific heat gamma. It is moving with a speed v and is suddenly brought to rest. Assuming no heat is lost to the surrounding, its temperature increases by. Now here, half capital M V square will be equal to CV delta T. Half capital M V square equals to R divided by gamma minus 1 delta T. That is basically CV can be written as R divided by gamma minus 1. So delta T would be equal to M V square gamma minus 1 divided by 2R, which would be basically can be written as gamma minus 1 M V square by 2R. So your correct answer would be option D. Question 17. 200 calorie of heat is given to a heat engine so that it rejects 150 calorie of heat. If source temperature is 400 Kelvin, then sink temperature is. Now Q1 is 200 calories, Q2 is 150 calories, temperature 1 is 400 calories, we have to find temperature 2. So Q1 by Q2 will be equal to T1 by T2. Directly we can get value of T2 from here as Q2 divided by Q1 multiplied by T1, which would give us 300 Kelvin as the answer. So option A would be your correct answer. Question 18. When the temperature of a gas is raised from 27 degrees Celsius to 90 degrees Celsius, the percentage increase in the RMS velocity of the molecules will be. Now Vrms is directly proportional to root of T. So V2 by V1 will be equal to root of T2 by T1. Temperature increases from 27 to 90. So basically this would be 273 plus 90 divided by 273 plus 27, which will be 1.1. So from here we can say that percentage increase would basically be V2 minus V1 minus 1 into 100, which is 0.1 into 100. So that is basically 10%. So your correct answer is option A, 10%. Question 19. 5 identical springs are used in the following 3 configurations. The time period of vertical oscillation configuration 1, 2 and 3 are in the ratio. So for each of the configuration, basically the ratio of the time periods of each of the configurations. Now T time period is inversely proportional to root of K. So T1 is to T2 is to T3 would be equal to 1 upon root of K is to 1 upon root of K by 2, as this is in series, is to 1 upon root of 2K for the parallel combination. So in parallel combination the K gets added up, in series combination it is basically K into K divided by K plus K. So this, now the K can get cancelled out and I will get 1 is to root 2 is to 1 by root 2 as the final answer. So your correct answer here is option A. Question 20. The length of a spring is L and its force constant is K. When a weight W is suspended from it, its length increases by X. If the spring is cut into 2 equal parts and put in parallel and the same weight W is suspended from them, then the extension will be. Now the spring is cut into 2 equal halves. So spring constant of each part will be 2K. Okay. These parts are parallel. So your equivalent K would be 2K plus 2K, that is 4K. So extension force, which is given as Kx, would be 4K into X dash equals to Kx. Why? Because force initially applied and finally applied is the same. It's just that the value of K has changed now. So initially it was Kx, now it is 4K X dash. So your X dash from here will be X by 4. So correct answer would be option D. Question 21. A closed organ pipe and an open organ pipe of same length produce 2 beats per second while vibrating in the fundamental modes. The length of the open organ pipe is half and that of closed organ pipe is double. Then the number of beats produced per second while vibrating in the fundamental mode would be. Now, open frequency minus closed frequency equals to 2. Frequency of fundamental mode of a closed organ pipe, that is Fc, is given as 4 by 4 Lc, and that of the open organ pipe F0 is given by V by 2 L0. So Lc and L0 are equal, which allows us to say F0 would be equal to 2Fc. So from equation 2, that is basically this equation, I can say that F0 is equals to 4 Hertz and Fc is equals to 2 Hertz. Now this is based on the initial condition. Now when the length of the open pipe is halved and that of the closed pipe is doubled, so what will happen is F0 dash will now become V by L0, that is because L0 is halved, and Fc dash would now become V by 8 Lc. So now here I can say that F0 dash is basically, or you can say Fc is basically Fc dash is basically half of your original Fc. So your original Fc was 2, so Fc dash would be 1 Hertz. And since this is 1 Hertz, and since you also know that F0 is 4 and your new F0 is double that of the original, so F0 dash is nothing but 2 times F0, so this would be basically 8. So the number of beats heard would be 8 minus 1, that is 7. So correct answer would be option B. Question 22. There are two charges, 1 microcoulomb and 5 microcoulomb respectively. The ratio of the forces acting on them is. Same force will act on both these bodies, although their directions will be different because both are positive. So correct answer would be option B, 1:1. Question 23. A simple pendulum has a length L and the mass of the bob is small m. The bob is given a charge of q coulomb. The pendulum is suspended between the vertical plates of a charged parallel plate capacitor. If E is the electric field strength between the plates, the time period of the pendulum will be given by. So basically, if I represent it diagrammatically, this is what it looks like. These are the charged plates. This is what the pendulum is. Pendulum is given a plus q charge. And this is how the electric field is. So as we know, time period of a normal pendulum is 2 pi root of L by G. When it is suspended between vertical plates of a charged parallel plate capacitor, then there will be certain amount of acceleration that will be produced. So A will be equal to QE by small m. This acceleration is acting horizontally and acceleration due to gravity is acting vertically. So effective acceleration, that is G dash, would be equal to root of G square plus A square, which will be equal to root of G square plus QE by m the whole square. So I have got the value of G dash. So your T dash, that is the new time period, will be 2 pi root of L by G dash. So put the value of G dash here. So your correct answer here would be option D. Question 24. The equivalent capacities between the points A and B in the following circuits are. Now this is basically 15 microfarad, 15 microfarad parallel. That will get added up to, this is 1.5 microfarad and 1.5. So 1.5 microfarad will become 3 microfarad. That 3 microfarad and these two are in series. So series combination of the 3, that is 1 by C will be equal to 1 by 3 plus 1 by 3 plus 1 by 3. So on solving this, you will get the resultant C as 1 microfarad. So correct answer is option A. Question 25. In a copper voltmeter, the mass deposited in 30 seconds is m gram. If the current time graph is as shown in the figure, the electrochemical equivalent of copper in gram per coulomb is. Now here, if you look at the graph, the average current would be 50 plus 100 plus 50. So divided by 3. So that would make it 200 by 3 milliamperes. Z would be equal to m by IT. So M 3m divided by 200 multiplied by 10 raised to minus 3 multiplied by 30. So finally it will give you m by 2 as the answer. Your correct answer will be option C. Question 26. Two similar cells, whether joined in series or in parallel, have the same current through an external resistance of 2 ohm. The internal resistance of each cell is. Now here in series circuit, I1 will be equal to 2E divided by 2 plus 2R. In case of a parallel circuit, I2 will be equal to E divided by 2 plus R by 2. So this will basically mean 2E divided by 4 plus R. Now, since we know I1 and I2 are equal as given in the question, we can say 2E divided by 2 plus 2R will be equal to 2E divided by 2 plus 4 plus R. So on solving this, we will get the value of R as 2 ohm. So the correct answer is option B, 2 ohm. Question 27. Silver and copper voltmeter are connected in parallel with a battery of EMF 12 volt. In 30 minutes, 1 gram of silver and 1.8 gram of copper are liberated. The power supplied by the battery is. So silver and copper are connected in parallel. Battery has an EMF 12 volt. So here in this question we can say current I1, that is for silver voltmeter, would be N by ZT, which is equal to 1 divided by 11.2 multiplied by 10 raised to minus 4 multiplied by 30 multiplied by 60. So we get the value as 0.49 amperes. For copper voltmeter, I2 will be 1.8 divided by 6.6 multiplied by 10 raised to minus 4 multiplied by 30 multiplied by 60, which should be 1.5 ampere. Total current I would be I1 plus I2, which will come out to be approximately 2 amperes. So power would be equal to IV, which is 2 multiplied by 12, which should approximately be 24 joule per second. So your correct answer approximately would be option A, 24.13 joule per second. Question 28. The current I is flowing through the loop. The direction of the current and the shape of the loop are shown in the figure. The magnetic field at the center of the loop is mu 0 I divided by R times MA equals R, that is the radius, MB equals to 2R, and angle DMA is 90 degree. So here first thing is that magnetic field at the center due to the curved portion DA would be mu 0 I divided by 4 pi R 3 pi by 2. So because of the curved portion DA, this is what the magnetic field. Basically I get 3 pi by 2 by eliminating the 90 degree here from the rest of the angle. So according to right hand screw rule, the magnetic field will be into the paper because of the direction of current that is given to us. Second thing, magnetic field at M due to AB would be 0. So due to AB, it would be magnetic field would be 0. Third thing, magnetic field at the center due to the curved portion BC would be mu 0 I divided by 4 pi 2R multiplied by pi by 2 because the angle is pi by 2. According to the right hand screw rule, here the magnetic field will also be into the paper, plane of the paper. And the fourth thing would be magnetic field at M due to the part DC would also be 0. Hence the resultant magnetic field would be nothing but 0 plus this part, that is DA, and because of the part BC. So when you add both these parts, you will get your answer as 7 mu 0 I divided by 16 R. So that basically means 7 by 16 but into the plane of the paper. So correct answer would be option D. Question 29. The bob of a simple pendulum is replaced by a magnet. The oscillation is set along the length of the magnet. A copper coil is added so that one pole of the magnet passes in and out of the coil. The coil is short circuited, then which of the following happens? So here your correct answer, that is first it says period decreases, period does not change, oscillations are damped, and fourth option is amplitude increases. So correct answer here will be option C. Oscillations will be damped, that is because of the magnetic field that will be produced inside the coil. Question 30. At a place, if one Earth's horizontal and vertical component of magnetic field are equal, then the angle of dip will be. So BV is equal to BH tan phi. So if BV is equal to BH, then tan phi will be equal to 1. So phi would be equal to 45 degrees. So correct answer would be option C, 45 degree. Question 31. A uniformly wound solenoid coil of self-inductance 1.8 multiplied by 10 raised to minus 4 Henry and resistance 6 ohm is broken up into two identical coils. These identical coils are then connected in parallel across a 12-volt battery of negligible resistance. The time constant for the current in the circuit is. So you have to find what is the time constant for the current in the circuit. Now here self-inductance given to us as L, that is 1.8 multiplied by 10 raised to minus 4 Henry. R is given as 6 ohm. When self-inductance and resistance are broken up into identical coils, so self-inductance new one would become 1.8 multiplied by 10 raised to minus 4 divided by 2, and new resistance would become 6 divided by 2, that is 3 ohm. Now the coils are connected in parallel. So your resultant inductance would be 0.9 multiplied by 10 raised to minus 4 multiplied by 0.9 into 10 raised to minus 4 divided by 0.9 into 10 raised to minus 4 plus 0.9 into 10 raised to minus 4, which would give me the answer as 0.45 multiplied by 10 raised to minus 4 Henry. And for R dash it will be 3 parallel 3, that is 3 multiplied by 3 divided by 3 plus 3, which will be 1.5 ohm. So time constant would be L dash by R dash, which is 0.45 multiplied by 10 raised to minus 4 divided by 1.5, which would be 0.3 multiplied by 10 raised to minus 4 seconds. So correct answer here is option C, that is 0.3 multiplied by 10 raised to minus 4 seconds. Question 32. Two coil X and Y are placed in a circuit such that the current changes by 2 ampere in coil X and magnetic flux change by 0.4 Weber occurs in Y. The value of mutual inductance of the coils is. Now here phi would be equal to Mi. So M would be equal to phi by I. So that is 0.4 divided by 2, which is 0.2 Henry. So correct answer is option C, 0.2 Henry. If an 8 ohm resistance and 6 ohm reactance are present in an AC circuit, AC series circuit, then the impedance of the coil will be. So impedance Z would be root of R square plus X square, which will be equal to root of 8 square plus 6 square, which will give you answer as 10 ohm. So correct answer is option C, 10 ohm. Question 34. The atmosphere between the heights of 50 km and 80 km is called mesosphere. That is option A is your correct answer. In the figure shown, for an angle of incidence 45 degree at the top surface, what is the minimum refractive index needed for total internal reflection at vertical face? Now here, by Snell's law, mu would be equal to sine I, that is sine 45 divided by sine R. So from here I get sine R equals to 1 upon mu root 2. Now at point B, that is basically once this has gone inside, suppose this is my point B. So if I redraw the diagram, this is 45 degree my angle of incidence. This is my ray that has bent. So suppose this is point B. So at this point, this is 90, is my angle of refraction. This is my I1, that is angle of total internal reflection. So here for total internal reflection, sine of I1 would be equal to 1 by mu. So from the figure, I1 can be said as it is 90 minus R. So basically sine of 90 minus R would be equal to 1 by mu. So basically cos R would be equal to 1 by mu. Cos R is root of 1 minus sine square R. So sine R is 1 upon mu root 2. Substituting that, you will get the value of cos R as 2 mu square minus 1 divided by 2 mu square. So from this, that is cos R is 1 by mu, and here I get cos R value as this. I can say that 1 by mu is equal to root of 2 mu square minus 1 divided by 2 mu square. So from solving this, we will get value of mu as root of 3 by 2. So correct answer is option B, root 3 by 2. Question 36. Which of the following is a wrong statement? A, D equals to 1 by F, where F is the focal length and D is called the refractive power of a lens. Option B, power is expressed in diopter, where F is in meter. Question C, power is expressed in diopter and does not depend on the system of unit used to measure F. Option D, D is positive for convergent lens and negative for divergent lens. So here actually your option A, B and D are correct. That is, they are right statement. Option C is the wrong statement. That means correct answer would be option C. That is, power is expressed in diopters, but yes, it depends on the system of unit that is used by F. That is the correct statement. And here the statement says that it does not depend on the system of unit used for F. But actually in reality, it depends on the system of unit that is used for F. Question 37. If white light is used in Young double slit experiment, what happens? A, no interference. B, white fringes are formed. C, central bright fringe is white. Or option D, central bright fringe is colored. So which of the options is correct? Here option C is correct. So when white light is used in the Young double slit experiment, then different colors will be split up on the viewing screen according to their wavelengths, while the central fringe will always be white. So the central bright fringe is white. That is the correct answer. Question 38. The photoelectric threshold frequency of a metal is V. When light of frequency 4V is incident on a metal, the maximum kinetic energy of the emitted photoelectrons is. Now, according to Einstein's photoelectric equation, kinetic energy would be equal to h nu 1 minus the work function. So work function is h nu, and here it says your nu 1 is equal to, that is, the new frequency is 4 times the original frequency. Substituting all of that, Ek would be equal to 4h nu minus h nu, which will be equal to 3h nu. So 3h nu would be your correct answer. That is option B. Question 39. Positive rays are very identical to. Now positive rays are very identical to alpha particle rays. Question 40. In an hydrogen atom, the electron moves around the nucleus in a circular orbit of radius 5 multiplied by 10 raised to minus 11 meters. Its time period is 1.5 multiplied by 10 raised to minus 16. The current associated with the electron motion is, and the charge of the electron is given to you. Now we have to find the current associated in this case. So here the correct answer would be actually 1.6 multiplied by 10, 1.66 multiplied by 10 raised to minus 3 amperes. That's the standard value for current associated with electron in hydrogen atom.